everyone, and welcome to Grantham Physics 220 lab videos. So what I'm going to do also, in addition to the lecture videos each week, is I'm going to do some steps on how to work and go through the lab. And with this being week 1, the first thing I'm going to do is show how to install the lab. So I'm going to put in the software disk real quick here, and it should bring it up, and then I will literally just kind of step through what the installation process is going to be. So we see the contents of the disk here, and I hit run, and you'll see that it wants to record that. And you'll bring the interactive physics up. We hit next, your normal license agreement. You want to select SI units. That's important, but that's what we want to use in this class. Pick your, just usually the default location to let it install. And this will run through relatively quickly here. Okay, so now we get to the point where it says the interactive physics wizard is done. You hit finish, and it will open it up. Now, at this point, you have the blank program open. What I want to do is switch over to the actual interactives that are included with the course and go from there. So I'll show you how to do that. So now at this point, I'm just in a development shell. If we click the all simulations can be downloaded, we can click here. Notice it opens a zip file where we want to actually put these. We can download those and work. If I hit save, you pick your specific point, and then we go from there. Now I already have these downloaded and obviously installed, so I'm just going to go over and open our first one up, which if we notice is experiment1.ciip.ip. So here we are. Here's all my lab files, and we're going to open experiment1.c1.ip. It will open into it. Notice it will say for educational use only. Jumping over to our lab instructions now, we see what we're looking for. Notice it follows basically what we're doing. It tells you the lessons as follows, the textbook pages, and it tells you the experiment we want to do and how to open it. It says you want to run the simulation, use the data from time position measurements to fill in the data table below in the indicated times. Then graph the data on the graph paper provided in the answering sheet in order to construct a D versus T or X versus T graph. Calculate the answers to the lab sheet to be handed in after all the labs are completed. It's actually just talking about this lab in particular. You want to calculate all these different items and then go from there. Okay, so here we are in our actual experiment. You notice there's a couple different things you can do. There's actually a lot of different things you can run through. Notice if you just hit run, the ball will just roll over a period of time. Notice its position, X and Y, as a function of time, the rotational velocity, which we were not going to really work with here. And then eventually we'll roll to the end, and I'm assuming at some point fall off. Now at any point you can hit stop, and if you are missing what's going on, you can always go back and hit reset also. There's a lot more here than we actually are going to use in this lab. So again, you can hit run, stop, reset at any point. You can resize the window. I had to resize it for some issues here, but this is primarily what we're going to do through here. So what we're looking to do here is find the position as a function of time. So the one we are concerned with is the X position. Notice, if I hit run, the Y position doesn't change. And again, if we go back and reset. Now, notice if I hit run and let it run for a little bit, that one of the things we can do with this little slider here is there is a back that's very, very, very sensitive to my clicking. So you can easily move this around back and forth relatively simply. So going back again to our lab here, and the last thing I was leaving on is how you can move through this. What you're going to do is look over at the data table, and you want to find the average value for specific ranges of question. So you're literally going to make plots of the position versus time. You can reset this back and literally pick certain time intervals, even maybe as detailed as a tenth of a second, and do the position. So for the first one, at 0.1 seconds, it's at 0.1 meter. Maybe at 0.3 seconds, it's at 0.3, so on and so forth. You're going to find the intervals that work the best for you. And notice all I did was there is just move where the position of the little board was. Eventually, at some point, you'll notice, especially if you let time really go normally, you notice that it no longer syncs up exactly. It was while they're matching up exactly where for every tenth of a second it moved a tenth of a meter. So they say use the graph paper supplied, but I think a good point to do sometimes with these is maybe actually use a graphing tool like Excel to actually work through this. So what we see I have here is a data table setup of distance versus time. Set the borders up. So for example, for our data here, if I go all the way back and I hit run, and I can back up, let's say I do an iteration of, I don't know, let's say 0.2 seconds. So going back to 0.2 seconds, it's at a distance of 0.2 meters. Okay. And then if I wanted a little more, 0.3 meters. Now, I'm not going to do the whole lab for you, so let's just say I'm going to make up some numbers at this point. And one thing I do want to point out, if you want to do in tenth of second intervals, it's actually really nice. You can pick a few and say go down and click fill series, and it will do every tenth of a second. So what I'm going to do now is just make up numbers. Okay. How you're going to make a plot is you're going to highlight the ones in interest. You're going to hit insert, come over here, and there's charts. And what we always want to do is you always want to do a scatter. And I would always suggest the dots and the curved line to fit it, or even line like this. I always like to use smooth lines because it gives a better idea. Although in this case, you probably want to use a jagged because it's going to move a lot smoother. But you can see literally what's happening there. You can rename this. Position versus time as such, and even name the axes labels later. The other thing it's asking for, again, if you notice over here, it's asking for the slope at the points. So there's ways to calculate the position versus time at certain points. Remember, slope is x over time in this case. So it's the change in position divided by the change in time. If you put all that together, look at it in the details, follow the instructions I've given. Again, remember, these distance data are not actually what is going on. I was just using examples. You should be able to get a nice, decent understanding of the physics of the problem and see how position and time connect together and help you get a basic understanding of kinematics and physics.